Floating in space, a spectacular sight. Imagine the sensation of weightlessness, the freedom to move in any direction without the constraints of gravity. It's a dream that many have had, but only a few have experienced. Have you ever gazed up at the night sky and wondered what it would be like to float among the stars? The vast expanse of the universe, dotted with countless stars, planets, and galaxies, has always been a source of wonder and inspiration. The night sky, with its twinkling stars and the majestic Milky Way, invites us to dream of adventures beyond our world. Imagine astronauts effortlessly gliding through the International Space Station, their hair standing on end, objects magically suspended in midair. In this unique environment, everyday activities take on a new dimension. Simple tasks like eating, drinking, and even sleeping become extraordinary experiences. The absence of gravity allows astronauts to move in ways that are impossible on Earth, creating a surreal and mesmerizing spectacle. It's a sight that has captivated humankind for decades, a testament to our insatiable curiosity about the cosmos. From the early days of space exploration to the present, the image of astronauts floating in space has become an iconic symbol of human ingenuity and the relentless pursuit of knowledge. Each mission to space brings new discoveries and deepens our understanding of the universe. But what exactly causes this peculiar phenomenon? What makes it possible for astronauts to float effortlessly in space? The answer lies in the unique conditions of the space environment, where the force of gravity is significantly reduced. Why do astronauts float in space? The key to this mystery is a fascinating concept called microgravity. In space, objects are in a state of continuous freefall towards Earth, but because they are also moving forward at a high speed, they create a sensation of weightlessness. This delicate balance allows astronauts to experience the wonders of floating in space. The answer lies in a fascinating concept called microgravity. Microgravity is not the absence of gravity, but rather a condition where the effects of gravity are greatly diminished. This creates an environment where objects and people appear to float, providing a unique and invaluable opportunity for scientific research and experimentation. Prepare to embark on an exhilarating journey as we delve into the science behind this captivating phenomenon and explore how it shapes the experience of space travel. From the rigorous training that astronauts undergo to the incredible experiments conducted in microgravity, we will uncover the secrets of life in space and the groundbreaking discoveries that continue to push the boundaries of human knowledge. Join us as we venture into the final frontier and witness the awe-inspiring spectacle of floating in space. Contrary to popular belief, astronauts don't float because there's no gravity in space. Gravity is everywhere in the universe, holding planets in orbit and dictating the celestial dance of stars. The Earth's gravitational pull, for instance, keeps our moon from drifting away. So, if gravity is omnipresent, why do astronauts appear weightless? The answer lies in a concept called microgravity. Microgravity doesn't mean there's no gravity, it simply means the force of gravity is significantly weaker than what we experience on Earth. To understand microgravity, we need to consider how objects move in space. In the vast expanse of space, the rules of motion are quite different from what we experience on Earth. Here, gravity is a constant force pulling everything towards the ground. But in space, things behave in ways that might seem counterintuitive at first. Imagine throwing a ball horizontally. On Earth, when you throw a ball, it travels forward for a while before gravity pulls it down to the ground. It travels forward but also curves downward due to gravity, eventually hitting the ground. This downward curve is a result of the gravitational pull that constantly acts on the ball, pulling it towards the center of the Earth. Now imagine throwing that ball with enough force that its curved path matches the curvature of the Earth. In this scenario, the ball would keep falling towards the Earth, but because the Earth is curved, it would never actually hit the ground. Instead of crashing, the ball would continuously fall around our planet. It would be in orbit. This is the principle behind how satellites and spacecraft stay in orbit around the Earth. They are moving forward with such speed that their path curves around the Earth, creating a continuous free fall. This is precisely what happens with the International Space Station, ISS. The ISS orbits the Earth at a speed of about 28,000 kilometers per hour, which is fast enough to ensure that it keeps missing the Earth as it falls. The ISS is constantly falling towards Earth, but its horizontal speed is so great that it keeps missing our planet, resulting in a continuous state of free fall. This creates a microgravity environment inside the station, where astronauts experience weightlessness. They float around, not because there is no gravity, but because they are in a constant state of free fall, just like the ISS itself. This unique environment allows scientists to conduct experiments that would be impossible under normal gravity conditions, providing invaluable insights into various scientific fields. Imagine jumping off a diving board. For a brief moment, you experience a sensation of weightlessness, as if gravity has momentarily vanished. This is because you and the diving board are both falling at the same rate. Similarly, astronauts on the ISS are in a constant state of free fall alongside the space station itself. They're falling together towards Earth, creating the illusion of weightlessness. It's like that feeling of jumping off the diving board, but it lasts indefinitely. Section 5. Astronauts' Tales from Space. Astronauts often describe the feeling of weightlessness as both exhilarating and disorienting. Everyday tasks like eating, sleeping, and even using the bathroom become intriguing challenges in microgravity. Imagine trying to eat soup from a bowl while floating. It would be a recipe for disaster. Astronauts have to adapt to this unique environment, developing innovative solutions for everyday living. Section 6. Training for weightlessness. A dive into the deep end. Preparing astronauts for the challenges of microgravity requires rigorous training here on Earth. One of the most effective methods involves submerging astronauts in giant pools of water. These neutral buoyancy labs, as they're called, simulate the feeling of weightlessness, allowing astronauts to practice spacewalks and other tasks in a controlled environment. Section 7. The Vomit Comet, Zero Gravity on Earth. Another intriguing training method involves parabolic flights aboard a specially modified aircraft nicknamed the Vomit Comet. By flying in a series of steep climbs and dives, the aircraft creates brief periods of near weightlessness. These parabolic arcs provide astronauts with a taste of microgravity, allowing them to adapt to the sensation and practice maneuvers before venturing into space. Section 8. Living in microgravity. Adapting to a new reality. Living in microgravity for extended periods has profound effects on the human body. Without the constant pull of gravity, muscles and bones can weaken, and fluids can shift upward, causing changes in vision and balance. Astronauts engage in rigorous exercise routines and follow specialized diets to mitigate these effects and maintain their health during long-duration space missions. Section 9. The International Space Station, a marvel of microgravity. The International Space Station, a technological marvel orbiting 250 miles above Earth, serves as a testament to humanity's ability to overcome the challenges of microgravity. It's a testament to international collaboration and scientific endeavor. Aboard the ISS, astronauts from around the world conduct experiments, make groundbreaking discoveries, and push the boundaries of human knowledge. Section 10. Beyond Floating. The Future of Space Exploration. Understanding microgravity is crucial for the future of space exploration. As we venture further into the cosmos, we need to develop technologies and strategies for living and working in this unique environment. From designing spacecraft capable of artificial gravity, to developing countermeasures for the long-term effects of weightlessness, our journey into space depends on unraveling the mysteries of microgravity. Section 11. Conclusion: Unlocking the Secrets of Space. The sight of astronauts floating in space is a captivating reminder of the wonders that await us beyond Earth. These brave explorers, suspended in the vastness of the cosmos, symbolize humanity's relentless pursuit of knowledge and discovery. Their presence in space is not just a testament to human ingenuity, but also a beacon of hope for future generations. By understanding the science behind microgravity, we gain a deeper appreciation for the challenges and triumphs of space exploration. Microgravity affects everything from the way plants grow to how fluids behave, offering unique opportunities for scientific research. The experiments conducted in space have the potential to revolutionize medicine, technology, and our understanding of the universe itself. As we continue to unlock the secrets of space, we pave the way for a future where humanity can venture further into the cosmos, driven by an unquenchable thirst for knowledge and a profound sense of wonder. Each rocket launch, each mission, brings us one step closer to new frontiers. The imagery of distant galaxies and stars reminds us of the infinite possibilities that lie ahead. Our journey into space is not just about exploration, It's about understanding our place in the universe and the endless potential that awaits us.